to unmute us. We've been muted the whole time.
Great.
Oops. Noob. Good thing no one was watching.
Yeah.
Woohoo! Okay, now people can hear us on the stream.
Yay.
Let's go.
Um, I don't know what it's doing. 5 times 3, 15 plus 13 is 28. But then, oh, it's just times and add 13. Okay. What? No. That one is
42.
42 plus 13. This one is 20 plus 1, though.
Oh no.
Um,
Good try. Didn't work. We can get it with some more experimentation.
uh,
Sometimes I like, when I have problems like this, to ignore either the first or second number. Which one do you want to ignore first?
the first number?
Hey, do you see any relationship 3, 6, 5 with these?
None of them are factors.
Mm-hmm.
Oh, they all multiply to one short of the actual
Nope.
number. So 3 times 9 is 27. 6 times 9 is 54. 5 times 4 is 20.
So they're all a multiple of the second number plus 1.
Hmm.
Okay, now we see if we can find a pattern with just the first numbers.
Okay, none of them are factors again. 4 times.
Well, you said multiple plus 1, so what would the multiple here be?
Well, this one would be 25 plus 3. But then the 7 won't. 55 minus 3 is 52, and 7 is not a factor of 52.
So it'd be 49 plus
49 plus 6. 4, 5. So it'd be 20 plus 1 again. That does not make a whole lot of sense.
Okay, but maybe if we combine them, we can see something.
Um, oh,
Ah!
kind of see something. Because the 3 and the 6 match up, but the 1 is the only one that doesn't match up.
The 3 from 25 matched up. The 6 matched up.
Right. But the 1 is the only thing that didn't.
So what's
Um,
25 and 49 to 5 and 7?
oh, they're the squares. So 4 squared and then plus 5. Okay. So then the last one would be 9 plus 8, which is 17.
That is correct.
Hmm.
First one squared, plus the second one. We have our first viewer as well. Hello, Octoon. Welcome back. They celebrated with a yay and a thing, a celebration thing. Super cool. Okay, awesome. Okay, it's time to get to know Ananya a little bit. So we're going to have a little impromptu discussion. Let me just fix our cameras a little bit. There we go. Awesome. Okay, looks like chat is broken and you're called Blake. Rusty. I'm Rusty.
Oh.
Okay. Blake, nice to get to know you.
Nice to meet you, Rusty.
Thank you. So, if you won't mind telling our audience who you are and how you got to EMC.
Well, I started homeschooling when I was in 6th grade. Because I'm a dancer and we wanted to take my dance back to its roots. So I'm an Indian classical dancer and we wanted to go to India and kind of perform there and, stay there and, get some experience. So the year after I started homeschooling, wanted to get into some math and stuff, and EMC happened to be one of the vendors to my school. So through that, we got to know EMC, and like I fell in love with like the whole curriculum, the class, like the way they were teaching, like in the first class itself. So I was like, yeah, no, I'm sticking here for the rest of my homeschool journey. So for the past 2 years, I've been with EMC very happily. So it's definitely helped me a lot in math and reasoning in general, because it doesn't just give you like formulas and be like, do this, do that. It's more like, really making sure you understand the concepts and can apply them. So yeah, really happy I'm here.
Awesome. And we love having you here. You're one of my favorite students, and that's one of the reasons I asked you to be on this show. So, yeah. So, we have some chatting messages back to you. Someone says, I love dancing too. I think they dance the salsa, if I recall,
Interesting.
if I know who this is. So, I might know. Excellent. Uh, so, you've been here for 2 years now. What's your favorite topic we've covered at EMC?
Oh, my favorite topic has been quadratics. I just love how I don't know, it's easy for me to wrap my head around quadratics.
Mm-hmm.
I just like the symmetry of it. So, yeah.
Mm-hmm. I dance all that I can learn, but I have not danced Indian classical yet. No, not just salsa. That's from
Well,
chat.
definitely something to try.
Something to try in the future.
Yes.
Awesome. Okay. And so just to get to know you a bit, do you have a favorite song or musician or something that you like to dance to?
Um, I generally take inspiration from wherever I can find it. So if
Mm-hmm.
any songs have nice melodies and rhythms,
Mm-hmm.
I do love listening to those. So like, I don't know. I do like musicals a lot.
Mm.
Um, Conceptual musicals. I don't know if you've heard of Epic the Musical. It's a musical on the Odyssey.
I
Um,
haven't seen that one, but
mm,
my wife will probably have seen it. My wife loves musicals, so.
it's more of like it was like a TikTok thing and it became like a huge thing in 2020.
Okay.
And so yeah, I really like those type of things and songs that have like deeper meanings in them. So
Very cool. On that note, do you have a favorite musical, movie, TV show?
mm, TV show,
I mean,
I
are you a Glee
would
kid?
Mm, I think TV show I like Arcane.
Oh,
So
yeah.
a little different from my normal thing taste, but that
Hmm.
was an amazing show. The characterization, arcs, and everything else was really cool there.
Yeah, the
Um,
animation style was my favorite as well. I love that show.
mhm.
So
Yeah.
that's something I learned about you now. We know you're a dancer, but are there any sports you're into?
I do want to get into volleyball. I did a volleyball camp one summer. Thought it was fun, so trying to get into that. I
Hmm.
also enjoy running a lot, so track and field may be something I would like to do in the future.
Hmm. We have a question from chat. Where do you take your dance classes? That might be a little
I
too personal.
yeah.
In a general city, maybe.
Yeah. My dance classes are
Southern
in San
California.
Jose.
Okay.
Yeah.
San Jose.
So,
Very cool.
yeah.
Awesome. Um, and what are some of your other hobbies other than dancing? Do you have
Mm.
arts and crafts or?
Yeah, I am a very crafty person. So anytime anyone's birthday comes up, I'm always making handmade gifts. So I crochet, I paint, I draw, and like anything in the book. So
Hmm.
I do love that. I love reading. Um, it's like a pastime for me. So I can get through like 11 books in 2 weeks. So
Hmm.
yeah.
Very nice. Favorite book of the last year? It's hard to pick
Mm,
one when you read that, but many. Yeah.
yeah. I think I really like 1984. I just read it
Hmm.
by George Orwell. I'm trying to get into literature a lot. So
Hmm.
that was my first, kind of dip into the water. But I really like that book and,
Hmm.
opened my eyes to a lot of things. So, yeah.
I hear that. I love that. Uh, I love how much he saw before it
Hmm.
happened.
Exactly.
Yeah, put it that way. Games. Is there anything you like to play or do you play board games, video games, cards with your parents? I don't know.
Mm,
Any hobbies like that?
not, not really like a game player. Um, I do like do stuff on like the Switch, like
Hmm.
cooking games and stuff, but not really too into that.
That's that's cool. And your favorite holiday?
Hmm. My favorite holiday is, I think, that's hard to pick. I think for me it's Diwali.
Hmm.
I just do like blowing up stuff, so
That's the blowing up with color one.
Holi is blowing up with color. Diwali is
Okay.
the firecrackers.
Oh, okay. Very
Yeah.
cool. Sorry, I'm not as versed in Indian culture,
You're good.
being a this type of Canadian. So glad to hear it. That sounds awesome.
Yep.
Okay. Any questions from the chat for Ananya before we move on from getting to know her? 1984. Wow, that's some serious reading. Very cool that you are dancing in the same city as this person. They're also in San Jose.
Nice.
It's my boss. But we have some more people in chat. If you are wanting to ask questions, please go right ahead. We won't answer that kind of question. We're not going to answer how old they are. It's rude to ask, you know.
Yeah. Never ask a woman her age.
Yep, I'm old. She's young, but not too young for you two. There you go. Okay. No other questions, then we'll get started on our next segment. which is competition style slides. She said earlier she's a rising junior. Someone asked your grade. And you already shared that, so I figured that was okay.
Yeah.
Okay, competition style slides. So we're going to be doing some challenging problems. Some of them are tricky, some of them have something to look out for, and always something to learn from. So, do you know what combinatorics is?
Not really, no.
Good. Combinatorics is the branch of math that studies how to count things. So, how to count anything from 1 to 3. We did that since we were babies. 1, 2, 3, 4. That's counting. But combinatorics is also things like how many lock codes will have 2 nines in them, or how many binary numbers will end in a 0, 1 of a certain length, or have 4 ones in a row in them, or something like that. So it's counting things that are not, they don't appear countable at first, but they're countable if you know the techniques. So Nick arranges 4 numbered coins, 3, 2, 4, and 8 below to make a 4-digit number. So the first number he made was 3,248. But he can shuffle the coins around in any order. What is the probability that the number he makes is even?
I think the only way this number could be odd is if the 3 was at the end.
So we have to end in a 3. So what about the other digits then?
The other digits can be arranged in any way, but as long as it ends in a 3, it's going to be odd.
Okay, so then we're just asking how many arrangements are there for the other 3 digits?
So you can do 2, 4, 8, 4, 8, 2, and then 2, 8, 4, 4, 2, 8, 8, 4, 2, and 8, 2, 4. So that's 6.
So there's 6 ways we can arrange these 3 digits. But we're asked for the probability. So what do I also need to know?
How many other ways you can arrange it for it to be even?
Yeah. How many total ways can I have made these numbers? So do you want to start listing them out? Or do you want to learn how to count them?
I probably want to learn how to count them.
That's probably a better way.
Yeah.
Okay, one of the first ways we learn to count, other than 1, 2, 3, is to count by position. So how many ways can I fill in position 1?
4.
After I've chosen that, how many ways are left to choose position 2?
3.
What do you think?
2, 1. So.
But what do I do with those numbers?
Multiply them.
Why would you multiply them?
To get the total number of ways it can be rearranged into any of those positions.
Absolutely. That is the correct answer, but I'm wondering, why do you think multiply? Why am I not adding them? Dividing them would be silly, but subtracting them also very silly. But why would we multiply instead of add or do some other operation with these?
Mm, not really sure.
Once I've chosen two, what are my branch? I could go branch in different directions. I could have one that starts with 2, 4, or
Hmm.
I could have 2, 8, or I could have 2, 3.
Right.
So for each choice I make for the first digit,
You you're multiplying by the other choices, available
mm-hmm,
choices.
yeah. So because I have 3 different paths and I have 4 different starting points, I have 4 times 3 paths.
Mm,
Make sense?
yeah.
Awesome. Okay, so what are the total number of arrangements then?
24.
Okay, 24 total.
Six
What
of
is
them.
the probability that it's even? 6 of them ended in 3.
So it's like 75% probability.
75%? How'd you get it?
Mm.
From 6 and 24.
Um,
For
well,
those who aren't
six.
aware. I know you know.
Six. Yeah, six arrangements is the number of odd arrangements.
Mm-hmm.
So then 6/24 is the probability of the arrangement being odd, which is 1/4. And then the remaining is the remaining 3/4. So that would be the probability of the number being even.
Awesome.
So 3/4 is 75%.
Super job. Well explained. Would you like to learn how to count again in the future?
I could use it, yeah.
You think that would be useful in the future someday?
Definitely.
Okay, just gotta put that back. Okay, awesome. You said you loved quadratics, so I brought you a quadratic equation.
Oh.
We want to solve for x, and there's a trick for this one.
Mm-hmm.
Well, what would you start with?
I would start by expanding both and then solving for the roots because each of them make a quadratic equation. So
Mm-hmm.
this would be one quadratic and then this would be one quadratic.
Mm-hmm.
So then expand, solve for the roots, and then do the rest afterwards.
So can I solve for the roots when I have not 0?
Yeah, bring that to the other side.
Okay, let's try it out. Okay, you want to expand them?
Yes. I'll just my thing first. Okay. Um, so this one would be x squared plus, or just x.
That's fine.
Um,
You can keep it that way.
yeah, and then times x. Okay. Um, and then right, I'm gonna solve for the this one first.
Mm-hmm.
Try to find the roots. Um, does this change anything? At least now when I'm solving for the roots?
Change what? By
Like,
what do you mean by change anything?
can I just do as I normally would, like try to find what multiplies to the constant and adds to the
Yeah,
or
you could factor it. It could be helpful.
Mhm. Mm,
Then we'll know like this was already factored too, so maybe that would be helpful.
yeah. Mm, so adds to middle term multiplies to, or is it the other way around?
Adds to the middle and multiplies to
Multiplies
the
to the constant. Yeah.
constant. Yeah.
Yeah. So that'd be 3 and 4, right? So
Mm-hmm.
x minus 3.
Minus.
Yeah, because x would be the root, right?
Oh, x equals minus 3,
Mm.
which means
No,
the bracket.
x equals plus 3, right?
Yeah.
Yeah. So then it would be x minus 3, x minus 4.
You're also rusty. That's okay. If we're factoring it,
Oh, I forgot about that.
that's okay.
My
If,
bad.
if you're factoring it, it's got to stay positive
Right.
for both. And that's
Okay.
because the signs are positive for both.
Yeah. Forgot about the adding. So yeah. So then we have the already factored form. So okay. Oh yeah, my bad.
No, it's okay. It just looks a bit like a minus 11.
Mm,
We didn't learn this in class. That pesky minus 18.
yeah.
Should we
Had it not
expand
been
it to a quartic?
sure, why not?
Sure. Why not? That's why. Because of that voice right there. Sure. Why not? I don't want to. Don't make me, Mr. Andy.
I said I like quadratics, not cortex.
Exactly. Oh, oh, forgot to turn my light on.
Okay. Ugh. Okay.
Then there must be a trick, right? What do you notice? What pattern do you see?
Mm, like in the work so far?
Yeah, in the factors you've got so far.
Mm, my factors are 3, 4, 1, 7, x.
Hmm.
They're all positive factors.
They're all positive factors.
Mm-hmm.
When I have always positive factors on a graph, what would that kind of look like?
It's like always going that way.
Where would the roots be if I didn't have this 18?
Um, Birds would be here, here, like Irish.
Close.
What?
We've got +3, so x has to be
Negative.
-3 for the touchdown.
Mm.
Okay, so
Wait.
we've got the roots on the left, right?
Mm-hmm.
So this is some quartic with roots on the left, and then we're moving the graph down by 18, which puts the roots down 18.
So it's all in the negative. And they're all complex.
They're all complex. So we have to find some complex roots. Oh no. Well, maybe not complex, but they're more complex than integers, it appears. Okay, let's try a little trick. Let's try rearranging these a little bit.
Mm-hmm.
Okay. X times x plus 4, x plus 1 times x plus 3.
I'm grouping them.
Let's expand each section.
Okay. This one. Alien. Mm. Was that
What do you
right?
notice?
Mm-hmm.
They have the same first chunk.
Mm-hmm.
Let's make that y.
Okay. So it's y times y plus 3.
Minus 18 equals 0.
Oh, that's a lot more helpful.
It is now a nice quadratic.
Mm-hmm. So that's y squared plus 3y minus 18 equals 0. And then adds to the middle multiplied to this. So it's -6 and 3.
-6 and 3.
Mm-hmm.
Y is -6 or 3. But what was y?
Y was x squared plus 4x.
X squared plus 4x is -6 or
3.
3. And now we have two nice quadratics. Not so nice. Might need a formula.
Yeah.
Do you remember the quadratic formula?
Yes. Negative b plus or minus the square root of b squared plus 4 minus 4ac over 2a.
Well done. Someone must have drilled that into your head.
I drilled it into my head. I needed it.
He kind of got you.
Yeah.
What method, though, gave us this formula? Do you remember?
That was a monstrosity. I remember that.
The monster. Yes, the
Yes.
monster.
Um,
We had to complete
complete the square.
the square. Okay, so we've
Yeah.
got this formula. A is the number, just for those who might have never seen this before, A is the number in front of the x squared term, B is the one in front of the x term, and C is the number when it's on the same side
The constant term.
as the constant term.
All right.
Okay.
So let me plug that in. Hold on. Okay. So we have B. I'm gonna solve the first one first.
First one first. Our A is 1. Our B is 4. And our C, we're going to put this over to the other side, is positive 6.
Yep.
So she's filling it in. She'll probably skip a few steps in simplifying here. So she squared the 4 right away.
It's negative
4 times 1 times 6.
Wait, wait. It's not undoing. Hello. Okay, there we go. Negative 4 times. Is that right?
Mm-hmm.
18 over 2.
There's our complex root.
Okay. So it's negative 4 plus or minus negative 8 square root of negative 8 over 2.
Sounds like an answer. We can stop there. What about the second one?
Wait, let me just write it down so we don't forget. Okay. Second one. That is
Almost the same. The only thing that changed was our C.
yep. Is it? It's plus, right? Yeah.
It'll, yeah, this 3 becomes negative when we bring it over. So the
Oh.
negative from that C will cancel with the negative here and make it positive. That's correct.
Yes. 2 plus 12. Oh, it's a positive discriminant. Yay. Mm-hmm. And then that is 28. So negative 4 plus or minus square root of 28 over 2.
Yep.
That's bad too.
And we can simplify those by pulling the 4 out of the root, but I think that's enough time on this question. What do you think?
Yeah.
Sounds good. We got our answers. Negative 4 plus or minus root negative 8 over 2. Negative 4 plus or minus root 28 over 2. Remember, when you're doing math, not every answer is going to be the nicest answer. You'll have some ugly ones in there. Ready for the next one?
Yes.
Okay. This one's from AMC, similar to AMC, the math competition, American math competition. The median of an isosceles triangle drawn to the base divides the altitude drawn to the leg into segments of 75 and 21 units, starting from the end of the base. Find the sides lengths of the triangle.
Okay.
Remember to trust the numbers and not your eyes. This is clearly, very clearly
No.
75,
That's
and that's
21.
21.
Yep.
Always trust the numbers, not your eyes, when you're doing geometry. Okay.
So median is the wait, let me get back to my geometry. Okay. Median is the thing that connects a vertex to the opposite side of
Yep.
the triangle, right?
But where? Am I
It
making a
goes
90-degree
straight.
angle
Yeah.
or am I going to the middle?
It goes to the middle of the midpoint of the
It'll go to
other.
the middle. Drops down to the middle.
Mm-hmm.
Okay? But because this is isosceles,
It is also the midsect, like that.
mm-hmm,
So these two sides are congruent. Two triangles are congruent.
yes.
And then the
Now,
altitude
one
is vertex
one
to
thing
other
to note
side.
is we use red and black. Those are separate equality notches,
Mm-hmm.
just for the audience's sake. Okay, go ahead.
And then altitude is vertex to opposite side, but it's perpendicular to the opposite side. So
Mm-hmm.
it's always at a 90-degree angle.
Mm-hmm.
Okay.
So this
Mm,
altitude here is at 90 degrees.
mhm. Find the sides of the triangle.
Oh my. Where do you want to start?
um Wait, I'm just trying to look at mm, we know that the 75 thing makes a right triangle there, but I don't know if that's like the best place to start.
Like this is a right angle as well?
No, this is.
Oh, okay. Yep.
That's the hypotenuse, but
Mm-hmm.
so it's c squared. I don't know if that's the best place to start though. I'm trying to find out where else.
Sure. It's always best to start wherever you feel makes the most sense. So let's label some side lengths though.
Mm-hmm.
Because it's opposite the angle C, we'll call this side little c. This side will be little a,
Mm-hmm.
and the whole bottom will be little b.
Right.
Let's call half of b O,
Oh, I see.
because we cut off half of b.
Yeah.
Okay, the other half of b is L, just so you know. Okay, so what formulas can I derive from this picture? What can I say is true?
We know that these two triangles are congruent
Yep,
with one
we
another.
sure do.
Mm, we can derive Pythagorean theorem from this.
We can look at the Pythagorean theorem. Okay, let's make as many Pythagorean theorems as we can. Maybe it'll pop out to us.
Okay.
Okay, let's start with this one here. A squared is equal to what?
A squared is O squared plus the middle. What did we label the middle segment as?
We need a letter for BM.
L squared.
I would have gone with H
Okay.
because it's the
Yeah,
height.
yeah.
Okay. A squared is O squared plus H squared. What about C squared?
C squared is also O squared plus H squared.
So we know what about A and O or A and C.
They're equal. They're
They're
congruent.
they're equal. We knew that because they're isosceles as well.
Yep.
Okay, I have another right angle here. What can I say?
Um, that is. Oh my. So it's c minus that length.
Okay, let's call that x.
So c minus x squared.
When I find that, it unlocks the whole puzzle, so make it x. C minus x squared plus
Plus 21 squared.
just 21.
Are we? Oh, we're finding. Okay. Then, 96 squared.
96 squared
Mm-hmm.
equals,
A squared.
oh, yep.
We're doing this
You're doing a
triangle,
different
right?
triangle than me. Oh,
Oh.
I just caught it. No, you're correct. Yours is a
Okay.
squared.
Okay. Yeah.
I was doing the bottom one. There's another one.
Oh yeah.
X squared plus 96 squared is equal to what?
Plus 96 squared is equal to B squared.
Which is, since I've already used O,
Is
2O
2O
squared.
squared. Yeah.
Okay. Time to start solving things. How can I adjust this? C is equal to?
C is equal to A.
Got rid of that.
Okay. So
I've got an equation with A and X and O and X. Is there a way to get this O to be A's?
um, that's 2O. Let me get the O to
Mm-hmm.
be X.
Well, let's see if we can find A in terms of X.
Okay. So I'm just expanding first. A squared minus 2.
A tough one.
Mm-hmm. So it's x squared minus 29x plus what's 96 squared?
Mm-hmm.
What's 96 squared?
A big number.
Okay, so then we'll just keep it as is, but it's a
Yeah.
constant term. Okay, so quadratic, yay. We solving for the quadratic?
Well, it's not 29x. We got an A, right?
Oh yeah, the
A
ax.
copy error. That's 2AX.
My bad.
It's K. I'm glad I caught it early. Okay. Can I solve a quadratic when I don't know when I don't know B? I know B is negative 2A, but or is that doable?
with a lot of algebraic manipulation, sure, but
Yeah, I don't want. That's too much time. We gotta. We're halfway through the stream already.
no.
Oh no.
Move on.
You want to move on?
No. Like,
Yeah. There's a trick. There's
mhm,
always a trick.
yes.
And this time, there's no way for you to have known the trick beforehand. So don't feel bad.
Okay.
Okay.
Thank
Gonna take
God.
all this stuff and move it down. Move it off to the side. We might need it later.
Mm-hmm.
Okay. When I take a triangle and I make a median, and it is an isosceles,
It
what do I know about these angles? What did I just do?
and you bisected.
I bisected them. Excellent. When I have bisected that angle, there's a theorem that you may or may not have heard of called the angle bisector theorem.
Mm-hmm.
If you haven't heard of it, you'll learn it in geometry with EMC next year. Okay? The angle bisector says that the length here in ratio to the length here is equal to the
The
length
length
here
here.
in ratio to the
Okay.
length here.
So
Okay?
basically, they're two similar triangles.
Yeah. So if we call this x, not the same as this x, just,
Mm-hmm.
you know, x is to 21 as a, little a, is to 75.
Mm.
So now I can replace up here where we had 2ax, I have an equation that tells me a and x is a relationship. Okay? So
Mm.
we can replace the a with how many x's?
No. Wait.
A equals
A equals 75x.
over
Over
21.
20. Mm-hmm.
We can simplify that a little bit. Divide by 3.
Mm. It's 7 on the bottom and like, oh, 25 on the top.
25 on the top. We've hit our limit. She needs a break soon, guys. I heard it. I heard it in the
No,
when
I was
having to
doing the
divide
hard
75 by
way.
3.
I was doing it the hard way. I forgot my basic division multiplication of x.
No worries. So we got 25/7 x. We put this in here, and for the sake of time, okay, we're going to find out that this is 100.
What?
I skipped a lot of algebra because
Yeah.
I don't want to spend too much time on one question. Okay, once I know that these are 100, how can I find the bottom?
Mm, the bottom, we just use the Pythagorean theorem again.
Yep.
Right.
I don't know my h though.
Um, Wait, then.
I just figured out that A is 100.
So 100 over 75 is equals x over 21. So 100 over 25 is 1 and 1/4.
X is 5/4. So this must be in ratio 5/4 to 100. Or 4/5. I jumped too far. Okay. So we have X is 5/4.
Yeah.
X was what? It was this
Mm-hmm.
in here.
Yes.
Okay. So that means this is going very steeply and just barely touching the top. So that means that this is just a bit bigger. And for the sake of time and our viewers' sanity, just so that they know, could it have been B?
No.
If I have two hundreds, what's my answer?
You. Wow.
It's okay. It was just staring us in the face the whole time.
Oh, that's annoying.
It's okay. Once you figured out one of the sides, you have to check. The only one that we would have to be careful of is if we got 120 for those answers. Okay, awesome. We've got 4 viewers. Say hello to Ananya. We're going to play a game in a little bit. We're just going to take a short little break to grab some water. And when we're back, we'll play a game. Please write any questions you might have for Ananya, myself, or a Q&A session for after the game. You can start writing those in now. So if you have some math homework that was giving you trouble in the middle of the summer, you can ask about it. Or if you have a topic you'd like to ask about, we can totally answer your questions as best we can. And so ask those away in chat. But we're going to take a short little break for a game in a second.
Okay.
Now we can turn our cameras off briefly.
Yay.
Woohoo! Hello! We are
Hi.
back. Thank you for your patience. We just have to, take a break sometimes to get some water. Today we're gonna play some caged Sudoku. It's kind of like Sudoku, but there are cages. Okay, these dotted bars are enclosing different regions, and the
Mm-hmm.
rules are similar to Sudoku. You have to have 1 to 5 in each of the cages, but also in each row and column.
So there's no squares.
There's, sorry, what? There's no squares?
Normally in the Sudoku, there's like you can't have the same number in a square, row, or
Correct.
column.
Yeah, the cages replace the squares.
Okay, got it.
So as you're figuring things out, please explain to the audience where you got it from.
Yes. Ooh, um,
For example, this row is only missing one number.
yeah,
What would it
we'll,
have to be?
we'll start there.
A 1.
Okay.
If you're watching in chat, you can play along with us. You can tell us where you'd like to put uh, a number. So say you wanted to put a number here, you could say the number above the red 5 is blank. Just put that in chat and you can play along with us at home.
I'm gonna go for the yellow square above the 5.
Yellow
That's
square above the 5.
yeah. I'm
Okay.
thinking either 1 or 2 would work there.
Yeah, we only have 2 options left, 1 or 2, because 3, 4, and 5 all see it.
Mm-hmm.
1 can't be here
Yeah.
because of this one. Okay. So always handy to write down the only 2 possibilities as well.
Mm-hmm.
If you are watching and you can chat, if you could just send us a quick message to make sure my chat is still working, that would be helpful.
This one can only be 2. Right.
Only be 2 because we've got 1,
We got
5,
1,
3,
5,
and
4 is in the same cage.
4 is in that cage.
So this guy's 3.
Excellent. Okay. Nails down quite a bit.
Yup.
That makes this pair what?
This one can be 5 or
These 2 as a pair.
oh,
Column wise, they can only be 1 or 4.
yeah. So this one has to be wait. 1 up here or no, other way around.
Yep.
And 1.
Yeah, because this 4 can see this box, it can't be a 1.
So then for this one, it would have to be 2 because there's already 1 here.
Mm-hmm.
And then the only other number is the 5.
Awesome.
Yay. Mm, and then also have the green one next. But a 2, a 4, a 3. So the only other one is 1 because there's a 5 already in the cage. And then
Mm-hmm.
all the other numbers are in the same row or column.
And then I think we can solve the yellow box
Yeah. Um,
in the upper right.
this one can be a 2 or so this is 5. because there's a 5 there, and then this has to be a 2.
Absolutely.
Alright.
She's on a roll. Can you beat Ananya? Send your answers in chat.
That's 2. 2, 5. Oh, my pencil keeps switching. 2, 5, 1, 1, 2. So that's either 3 or 4.
These are 3 4s.
Yeah. Wait, let me put that in the middle. And then this row can either be 3, 5.
If these two have to be 3
No,
and
wait.
4,
Yeah,
what
then
does
this
this
one
have
has
to
to be
be?
5. It has to be
Yeah.
5. Yeah.
You can also see that by looking at the other 5s.
Mm-hmm.
They cannot see this 5.
Yeah.
So it has to be in this row and column.
Mm-hmm.
So there were 2 ways to see it.
Yep. And then the only one left here is 3. So then that's 4. This is 3.
Mm-hmm.
Mm-hmm. And then 1 here, 4 here.
Absolutely. She solved it. Great job. Okay. This one's a little longer, maybe a little harder. We'll see.
Mm-hmm.
This game's called Ken Ken. Have you played it before?
I believe so. A long
Probably
time.
once with me.
Yeah. A while ago.
Okay. Similar to Sudoku in that we have the digits 1 through 6 this time are the
Mm-hmm.
only things we're allowed to put in there. And then each cage is a solid line, the thicker line. And each cage, not dash border, solid border, may only contain each digit exactly once. And when the operation is performed on those numbers, you'll get the answer in the clue. Okay? So we can start with a free 2 here because there's no operation. But what 2 digits between 1 and 6 will multiply to give me 20?
4 and 5.
So we know that these two have to be 4 and 5.
Oh, I see. And then what about the 3, the minus thing?
So it's in any order the operation is performed. So if I had a 6, this would have to be
Wait, so it's 3 minus or
I get 3 when I subtract. So that's what these
oh,
clues are like. So 6
okay.
and 3, we subtract and get 3.
All
Okay?
right. And then the divisible ones are divisible by 2.
Mm-hmm.
And then these two add up to 19, add up to 13. Okay, that makes sense.
Yeah. Okay, so what digits will give me 5 when I subtract them?
6 and 1.
So this has to be 6, 1 in some order.
Okay. Divisible by 2, it's
When divided gives 2.
oh. So 6 and 3 or 4 and 2.
Or,
4 and 2.
or, there's one
2
more.
and 1.
2 and 1.
Well, that's a lot.
A lot of options for the divisible by 2.
Okay.
Potentially good to check some others.
Yeah. The when subtracted gives you 4 is
Mm-hmm.
could be 6 minus 4 or 5 minus 1. Or 6 minus 2, 5 minus 1.
6-2 or 5-1.
Mm, the 3 gives you more options as you move on. Okay.
3's going to have a lot of options.
Mm-hmm. So
Maybe we should look at this sum.
the whole thing adds up to 19.
Yep.
Okay. 6 plus 3 is 9. Then 4, 5, 1. 6, 3, 4, 5, 1.
There's only 4.
Oh, never mind.
6, 3, 4, 5, 1 makes a 6. So we could have 6, 3, 4, 6. Or,
You can repeat.
as long as they're not in a row or a column.
Each cage may only contain each digit exactly once.
That's a lie.
Okay.
I might have copy pasted from the previous slide.
Okay.
Oops.
Yeah, 6, 3, 4, 6.
It's a row and columns can't repeat.
Mm, 5, 5, 5. That doesn't make sense. You can't.
Well, if we had 5 and 5, how much is left?
9,
How can I make 9?
6, and 3.
I think those are the only two possibilities.
Yeah, the rest of them would have too many repeating. And
Can I use this one?
no, because then this one would mess up.
This one would have the 5s showing up and
Yeah.
canceling out. If I did it, it'd have to be 5 here.
Mm-hmm.
So the only way to use this is have 5 down here. What about if I use this one? What do I know for sure?
The 4 would not have to be in either of these areas. So the 4 would have to be here. This
Okay.
could work. 6, 6, 3.
Okay, so it's got to be one of those two possibilities. So let's go with this one.
Mm-hmm.
If we run into any inconsistencies, we come back to this one. So we're on top answer.
Okay.
We're in case A.
uh okay, then 4 and 5 we still don't have to finalize it. It can be in
Can't
either of
resolve them
those.
yet, but
Yeah.
we can look in here now.
Mm-hmm. Because 6 and 3 are gone.
6 and 3 as a possibility were eliminated.
Mm-hmm.
What are the other
So
possibilities?
4 minus 1, 5 minus 2.
Okay.
We can't have 2 here.
Mm-hmm.
We could have 5 there if the 5 is not here and the 4 is there instead.
Okay. So let's try that possibility. So I'll put a red box around that second one. We're going with 5-2.
Yeah. So
We're going to test it. Because there's only one way to have 5-2, and that's have the 5 there and then the 2 there. Okay.
mhm. So then the
If
4 is here.
puts
5
a
is
5 there. And now we see what happens with these two cages and rewind to red if we can't make it work.
Yep. So then for the divides to 2, the only other option is the 1,
This has to be
which
1.
wouldn't work because then.
Mm-hmm.
So that doesn't work.
Okay,
So
so
no fight.
red does not work.
So it's 4-1.
So it has to be 4-1,
Mm-hmm.
which puts the 5 where?
Um, 5 can be down there, the bottom position.
Okay, because there's a 4 here. The 4 can't be here. It has to be on top.
Yep. Okay. And then what orientation? No, 4
There
has to be here and
can't
1
be a
has to.
4 in here now.
No, because this one, the 1 also can't match up with this. So this is a 6. Or 6-1 has to be.
Yep.
And then the
So
only
because there's
leftover.
4s already, we can't have 4-2.
Right.
We can have 2-1 or 6-3, but it can't be 6-3 because we already have 2 6s.
So it's 2-1.
2-1.
Okay. Hitting someone.
And we check what's left.
Um, got 5-3.
5-3. Do we know anything yet? Not yet.
No, sure.
Okay, I'm going to erase the red box because we found a possibility that got us to here.
Imagine after all of this, the 6-3-4-6 turns out to be wrong.
Well, we better hope. We better hope.
That'd be very frustrating. Okay.
Okay, so we have 2, 4, 6, 1. What do these have to be?
3-5.
Where's the 3 and where's the 5 have to be?
3. 3 would be down, or no, other way around. 3 here, 5 here.
Because
Because if there was a 5 there, then it wouldn't equal. You can't divide something by 5 and get 2
Yep.
in the numbers we're given.
Yeah. For 5, you can never have it in a divide by 2. Okay? And that gives us 4 numbers right off the bat. Very nice.
So I'm hoping we chose the right possibility.
We're really hoping we got it right up here.
Yeah. Okay. What next?
Where to?
The minus ones, we know we can't have a 6 or 2 for sure. So that leaves 5, 4, but that can't be up here, so no 4 here. So 5, 4 would have to be down here.
Okay. Let's write it in.
5, 4, and then 3, 2 would not work. Actually, 3, 2 could work. 3, 2
5,
could
4,
work
4,
in
3, 2.
3, 2 could work in either.
Yep.
So 3, 2 in the middle. 6, 5 wouldn't. 2, 1. 2, 1. 2, 1 could also work in. No.
Mm-hmm.
2, 1 wouldn't. Yeah, 2, 1 wouldn't work in either.
Mm-hmm. I think we need another let's go deeper
The bigger ones.
based on our choice. What happens if we choose 6 on top?
If we choose 6 on top, get one down there. Then
What does this have to be?
that has to be 5, 1.
5, 1. But in which order?
This order?
Yep. Okay. And then
Oh,
these are definitely 3, 2 now
yes.
in this blue scenario.
And if those are 3, 2, then whichever side 3 is on the opposite would be.
Mm-hmm. And then 5 would be on the opposite of whatever 5 is here.
Mm-hmm.
So I've got a 1, 2, and a 6. So where does the 4 have to go? In column 4?
4 would go, yeah, in this column, right?
Yeah. It has to go somewhere in this column. It has to go here
Mm-hmm.
in the blue scenario, which
Putting
makes
5 on the other
this
side.
5,
That 3.
this 5,
That's
this 2,
2.
and this 3.
That's 3.
No contradictions yet, so we can keep going with light blue,
Yep.
but if we run into a contradiction, we have to go back and flip this to 1, 6.
My God. Okay. We have 1, 2, 5, 1, 4, 5 here. So then this would have to be 6, 3.
Over here,
Mm-hmm.
which forces this to be
So that's 6, 3. That's 2.
and then these have to be
2. Wait, let me. My annotate thing is gone. Okay.
Mhm.
3, 6, 5, 2. So that's
These have to be 5 or
5 or.
based on the column.
Oh, I was looking at the row. My
Mm,
bad. 5 or 1.
5 or 1,
Mm-hmm.
which forces it to be
2, 5, 1, 7, 8. So the other two have to be 3 and 2.
so this could be 3, 2. So this 5 forces the top one to be 5.
Yeah. Oh no, we got a 5 here. So it's 1, 4, but it can't be 1, 4. It's 3, 2. I think we ran into a contradiction.
Where?
This has to be, these two squares for the 13
Mm-hmm.
have to be 1, 4 or
Yep.
3, 2.
They can't be
Oh
3,
wait,
2.
yeah, it can't be 3, 2. It can't be 1, 4 either, because the 1 is in the same cage as the 13.
Oh, remember that was a fake rule that I accidentally
Oh yeah,
kept
my
there.
bad. I
Nope, my
forgot.
bad. No, that was my bad. Okay, so it's got
Wait,
to be 1, 4
yes.
with the 1
So,
on top.
and the 4 and the 1. Yeah.
No
Okay.
contradictions for light blue yet.
Wonderful.
6 boxes left.
So
We better
this could
hope we
be.
don't get a contradiction here. We got to rewind so much.
Ooh.
Okay.
So we got 6, 3 here in the middle.
Mm-hmm.
If that's 3, and that's 1. 3, 1 is 1, or
Oh,
6, 4.
need a new color. So if we chose 3 here instead of 6,
Oh, it can't be 3, 1. Because the 1 is on top with the 2 divide thing. In the same column.
oh yeah, we've already got a 1 there.
Yeah, it can't be 3, 1.
Okay,
Okay,
so
so
it's
now
got to
we know
be
that 6, 4.
6, 4.
4 here, 4 on top. Okay, that
1.
narrows it
What's
down.
missing in these rows?
2, 2, and 3.
And those subtract to give us 1. Almost there.
Yep.
Woo!
And then 3, 6 down the home stretch.
We got it. Just got to clean it up for the audience.
That's a very beautiful puzzle.
Isn't it fun?
Yeah, we made the right choices. We didn't have to backtrack.
We did not have to backtrack.
Thank God.
We would have had to backtrack if we had the 5s.
Yeah.
There would have been a contradiction. But yeah, that was awesome. Great job.
Yay.
Okay, I hope you enjoyed watching us solve that puzzle as much as we enjoyed solving it. Next up is our Q&A segment. So if there's anyone in chat who has a Q for us to A, please type it in. I haven't seen any chats for a bit, so hoping there's someone who can type. We do have 4 viewers. 3 viewers. Someone wanted to leave right away. They don't like the Q&A segment.
Oh no.
No. Any final questions for Ananya as well? Because this is our last segment with her on the stream for today. I have invited her back for other Fridays, and she has kindly said yes. So it'll be Frynanya days. I don't know.
Nanya business days.
Yes. Fridays are Nanya business, guys.
Mm-hmm.
We'll get some Nanya business done.
Yes.
Is that a nickname for you already? Did you reuse it?
It was a second grade joke that the
Mm.
kids used to joke around with. So whenever we'd like me and there was this other girl named Ananya in my class. So whenever we go up to kids and talk, they'd be like, Nanya business.
Ananya business.
Yeah.
2 Ananyas in one class.
Yeah, I actually know and have been friends with 12 Ananyas now and counting.
Wow. That's
Yes.
a popular name then.
It's very popular.
Not, you're my first Ananya, so I wouldn't say I knew that, but I guess if you're culturally into that
Mhm.
group, you're gonna get a lot more.
The funny thing is, Ananya means unique. So the irony is just beautiful there.
Yes, that is hilarious. Well, our Ananya is unique to us. There's no question, so we're gonna let the audience know that we'll see you not next week because it is July 3rd, and therefore we're off for July 4th, Independence Day. But we'll see you in a couple weeks.
Yeah.
Thank you so much for joining us, Ananya. It's been a blast.
Absolutely. Thank you so much.
Awesome.
Bye-bye.
Bye, Ananya. Okay, and now we will see most of you later. Thank you for joining us. I hope you enjoyed our stream with Ananya. We will catch you in the future at EMC Live, and hope you enjoyed the show. Thank you so much for joining us. We'll see you later.